Hello. Hello, guys. Am I audible?
Yes, sir.
Okay, okay. Thank
I'm
you.
Dr. Chetana here, sir.
Hello, ma'am. This is Vishal here.
Yes, sir.
Vishal, how are you
Just
doing, ma'am?
another 2 minutes, we'll start, sir.
Sure, ma'am. What are the expected strength who will be attending, ma'am?
Probably around 100 we are expecting, sir.
Okay, okay. Maybe they have a lunch break.
Yeah, they have a lunch break, sir.
Okay, no problem. Let them join.
Yeah,
Right. So, like as soon as the strength comes more,
yeah.
I'll start off.
Yes, sir.
Okay. Thank you, ma'am.
Thank you. Okay.
So I think 40, 55 students have joined. Okay. Okay. So around 60 members are there. We'll just start in another 2 minutes or 3 minutes, right? Okay. 60 members are there.
Good afternoon, all. I would like to welcome you to the afternoon session. I would also like to welcome Mr. Vishal, who will be taking you through the cracking of C code, how exactly it is being done. Let it be an interactive session. So I expect the students to ask him questions. Okay. So I would now request Achetna Madam to introduce the speaker.
Good afternoon, students. And also, I also again welcome my colleagues, my HOD Shanti Krishna ma'am, Bharti ma'am, Ambika madam, and Jitendra madam and Neeta madam for this session also here. And I would like to introduce our guest of today, Vishal, Mr. Vishal Vanik, sir. So he is currently working as a technical lead in Q Spiders, and he holds an academic qualification with BE in Electronics and Communication, and pursue skill set to mention a few. It's C Advanced and C++ Advanced, HTML, XML, CSS, Visual Studio, MySQL, etc. So he has a previous experience worked as L&D head with Zest Tech Abstros P Bangalore, and training the trainers in the various organization on C and C++. To mention a few colleges he has trained is SJB Institute of Technology Bangalore, QSS Institute of Technology, and etc. So I welcome you, sir, again. So I hand over the session to Mr. Vishal, sir, now.
Thank you so much, ma'am. I'm first of all, greetings everyone. It's good afternoon. I'm really sorry that my camera isn't working, so that's a reason I'm not visible. Even if I turn on also, I'm not visible. I'm really sorry for that. And the first thing is, thank you so much for giving us an opportunity to work with you and your college, right? And so I have been told to take a training on cracking the C codes. So that is a workshop which is being conducted. And thank you so much for the opportunities. And like I would like to start now because it's already 1 o'clock, 5 minutes, right? Now, first of all, welcome every student, right? Now, here, your college has arranged a workshop for you guys. First, understand the importance of the workshop, right? Nowadays, many people, we find a different kind of people who have a different kind of mindsets. Cracking an interview, right? That is a concern, right? Now, there are a few things which you need to understand. Now, I will come to this screen later. First thing is you need to understand few things here. That is, right? Okay. So, what is your interview process? I think you might have been given an introduction for that. I'll just brief you with that interview process, right? So here, usually the first round consists of, right? First round consists of, many people have a misconception that it contains only aptitude, right? It contains only aptitude. No, the first round contains aptitude plus verbal. Some companies, right? Some companies, okay. And here, the one more thing is the most important part is technical program, right? Right. Plus, there is one more that some companies will use is MCQs or technical MCQs, right? Technical MCQs. So this is the first round. Usually, most of the companies will follow, right? Or they will. Some companies will skip about verbal, or some companies skip about the technical MCQs. But technical program, writing a program and executing is mandatory nowadays. Now, irrespective of any branch, right? Now, mechanical, civil people, they might ask like, why programming for us? Now, programming has become a tool to analyze a candidate, right, on their logical capabilities, right? It is not just a programming language means it's only meant for CSI students, right? It's not like that, right? Now it has become a tool for the companies to analyze or assess a candidate in a logical capabilities, right? They will give you a scenario based questions, or they will give you a snippets directly, right? So that is about the first round. The second round is, right, your face to face technical round, right? Some companies prefer to have third round as one more technical round, or third round will be HR, right? So here we will be discussing about the first and second rounds. So in the first round, we will be discussing about technical programs and also, right, technical MCQs, right? Now, one more thing I would like to highlight here is, right, most of the companies are conducting the rounds, first round globally, right, or national level. You can say that national level, right? First round is almost conducted by major MNCs at a national level. So there is no saying that, sir, we are not getting opportunities. First of all, keep that thing in your mind, right? Always you will have opportunity, right? So in that, like for example, you have TCS, you have Infosys, right? Infosys, and you have Wipro. Many companies are conducting a national level. These are the three examples which I'm giving you, right? Wipro will, TCS will call it as a TCS Ninja. Infosys will call it as a InfyTQ, and Wipro will call it as NLTH, right? National Level Talent Hunt Program. So for these kind of things, you guys should be very well prepared, right? So what are the things which are required, right? The first thing required, right? So there are, first is you need to be good at, right, one or the at least minimum one programming language. You should be good with that. Okay. Now, for example, since everybody, irrespective of any branch, everybody goes through that C programming. So this becomes the most easiest and convenient way of writing a program and understanding them, since you have already gone through that. Now, the way you study in academics is completely different from the way you have to study or prepare yourself for the placements. There's a lot of difference that we will see them here. You will understand how much you know, right, and how much you have to prepare yet. That you will understand when we start going through one by one examples, right? Now, that is one language. Along with that, one, right, concept is required, that is data structure. These are the things which are very essential for a placement, right? Now here, right, in C programming, your basic should be very strong, right? We say that advanced, right, concepts. Ma'am has just now mentioned that advanced concepts, that's what you are learning. No, advanced concept means, right, concepts are same. There is no nothing like basic or advanced concepts. Now here the advanced concept means it is up, they are talking about implementation. They're talking about implementation. A different approach or different kind of implementation is required to crack the interviews, right? Now I have faced a lot of situation wherein, right, one trainer will come to a college, he will give a programs and he will write a solution. Everybody will prepare on one solution for one program. Now when a company comes for a hiring purpose, when they are asking in a face-to-face round, if they are asking a questions, everybody is writing a same solution, right? Even though students know how it works, right, the interviewer comes in a confusion whether the students are mugged up, right, because everybody is giving a same solution, right? Same variable name, same solution. That is one concern, right? So you need to have a right idea about, right, one program, multiple solutions, right? One program, multiple solutions. So you need to have different logics or different algorithms, right? You should be able to implement, right? So that is the task which is, or that is the main concentration of the companies now, right? How a candidate is different from others. That is what they expect, right? So that has become most essential part nowadays for the interviews, right? Now just a second. Okay, I'm getting messages. Okay, not for me. Okay, now, so this is the basic idea about how interview will be, or what is the interview process, right? Sometimes they will take 1 day or 2 day or 2 weeks, depends upon the company policies or how convenient is for them, right? How many days it takes, nobody is sure about that. It purely depends upon a company to company, right? Now, coming back to what we are planning to do in the training or in this workshop, right? Now, coming back to point, right? So the workshop has been arranged as cracking C codes, right? It has been arranged as cracking C codes, right? Now, there are two things which you have to concentrate most importantly. That is MCQ questions you have to prepare. One is MCQ questions that you have to prepare, right? And another one is programs, right? Another one is programs. Now, when it comes today's task or agenda is, we will be practicing programs, basic programs with a different approach, and some are snippets based on operators and control statements. So that is what we will be concentrating today, right? Now, if you want to understand, right? How to crack MCQ question, right? The first thing is you need to understand working of operators, basic concepts, how it works, right? From which side to which side it works, what are the priorities of operators. These all things you need to understand, right? And then you should practice on snippets. Snippet is nothing but a small piece of code. Snippet is nothing but a small piece of code, right? Small piece of code where they will ask you to find the output, or they will ask you what is the error in that code, right? So you need to find out those things, right? So that you will be able to do only if your concepts are very clear, right? And most important task is how to become thorough with these things is you have to learn all the concepts through examples. That is the best way and a most successful way of learning things, right? Now, coming back to programming, implementing programs, right? Implementing programs. So you need to build a logic first. Come with one logic. For example, let's say I have some things. Let's say I want to do a prime program, right? So how do you decide the given number is prime, right? If the number is divisible by one end itself only, so you can't, because every number is divisible by one end itself. So how do you identify? There is a factor called as only, right? So you can use that and build it. That is one type of a common logic which is used by a student. Now there is one more logic which is called as a Sieve's algorithm, right? Sieve's algorithm. This is the most fastest way of, right? Which is the most fastest way of checking the given number is prime, or generating a series of prime numbers in a particular range or up to some number, right? So you need to come up with one logic, right? One logic, and then you need to identify which concepts should be used, right? Or which concepts I can use them, right? To implement the logic which I have designed. So decide on that, then write and execute a program. So to write a program, you need to follow the basic syntax, right? Basic syntax for writing a program. Now, when it comes to programs, we will be seeing counting number of set bits and prime number based programs, 2-3 varieties of programs. So first what we will do is, right, we will learn, right, small operators, right, and then we will work on one program, and then we will go with control statements, and then we'll come back to programs based on control statements, right? Control statements in the sense whether it may be a if else set or a switch, or it may be a loop, right? Any of the control statements, right? So this is the first part. Now coming back to the topic. Now the only way of learning is you have to ask questions. If you want to learn anything in your life, right, you need to learn, or you need to start asking questions. If you are not clear with something, you should always ask a question. That is the only way of gaining a knowledge. You can't simply sit and read and get idea about how to crack it, right? If you have some confusion, you should always ask questions, right? So this is the introduction which I wanted to give you. What is the interview process and what we will be doing today, right? All these stuffs, right? Now coming back to the first thing, right, I just want to see how much you guys are clear about the concepts which you have learned. Now let me make it clear, I am not judging anybody here. I'm not judging, or I'm not giving you marks, or I'm not giving you scores, anything like that. Just I want to understand, right, how much you know and how different way I can train you, right? Right. Just one example. Let's see it. So here is the example. You can have a look at it, right? You can try to solve it. So here is an example, right? Let's see who will get answer. So solve it. So I think messages are there. I hope I'll get to know when message comes. Fine. You can see a screen and send me the answers. So I'm waiting for your answers, right? Let me check. Still there are no answers. So we have 113 people in this session. At least I should get around 30-40 answers, man. Don't bother your answer is right or wrong. I just want to understand how much clear you guys are. Because I've been told your basics are, you have learned it. So that's the reason I want to understand from where I can start. Still there is no answer. My screen is visible. Am I audible? Kids?
Yes, sir, you're audible.
Thank you.
So please give them some time.
Okay, I'll give them time. No problem. Let them take time. If you have any confusion or a doubt, you can respond. You can ask. Okay. Okay. A is equal to plus and B is equal to 1. Okay. A is equal to 2 and B is equal to 1. Okay. I started receiving answers. So A is equal to 2, B is equal to 0, A is equal to 2, B is equal to 1, 1, 1, 1, 2. Okay. 1, 1, 1, 1. Okay. A is equal to 1, B is equal to 0. Okay. Arpita, can you clarify how many times the printf gets executed? Arpita R. So A is equal to 2, B is equal to 1. Sahas M. Can you justify, man? Okay, nice. Very good. I'm getting so many options here, right? That is what I like about your college. You people respond. That's called as a responsibility. Now, I got a lot of answers here that as A is equal to 2 and 1, 1, 1, 2 times gets printed, right? This is one answer. This is one answer. Now, first thing is, right, we need to understand what is happening in the condition, right? We need to understand what is happening in the condition. Now, right? So what is the operation we are doing? We are performing a logical OR operation, correct? Isn't it? So we are performing a logical OR operation. So what is the OR table? That everybody knows that, right? So everybody knows, right? The OR table is, right? If any one input is non-zero, then the output is true, right? Are we correct here? Right? If any one input is a non-zero, then right, output is true, correct? Output is true. Now, that is the property of OR, logical OR gate, right? Now, look at the scenario here, what is happening, right? Look at the scenario, what is happening here. So, compiler knows that you are performing a OR operation and A value is equal to 1, which we call it as a non-zero, right? Which we call it as non-zero number, and B is equal to 0, right? Now, when you are performing a OR operation here, if the first operand is non-zero, right? If the first operand is non-zero, then is there any necessity that I have to check the second operand? I can make a decision, right? If any one is non-zero, the output is true. So if the first operand itself is non-zero, the compiler will not check the second part or second operand. That part will not be evaluated, right? In logical OR operation, what happens is, if the first operand is non-zero, the rest condition will be evaluated as a true and rest of the expression will be skipped. Rest of the expression will be skipped. Are you getting my point? Are you able to understand? So condition becomes true here, right? And the rest of the expression gets skipped, means B plus plus is not evaluated. B plus plus is not evaluated. That means B value will remain same. So the output is 1 0 1 0, right? That is the output of this example, right? So the condition becomes true. It will go inside the if block. It will print A and B values, where B value is unchanged. B value remains a 0 itself, right? Because that part was skipped, right? That will not be evaluated, right? So what you can learn from this example is, for OR operation, if the first operand is a non-zero, then rest of the expression gets skipped. Are you getting my point? Right?
Excuse me, sir. Hello?
Yes, yes, please.
Sir, can you explain once again, sir?
Sure, I'll explain it. That's not a problem. Now, see here, what I'm trying to convey here is, right? What I'm trying to convey here is, let me clear the few things here so I can explain one more time. Okay. Now, the first thing you need to understand about logical OR gate, right? Or logical OR operator, right? If any one input is non-zero, the output will be true, right? You just now you saw the table, and you have learned it from the first year of engineering, right? The logical OR operator means if any one input is non-zero, then the output is true. Now there is a OR operation which I'm doing here, right? X or Y. If the first operand, right, first operand itself is a non-zero, if the first operand itself is non-zero, right, then there is no need of evaluating the rest of the expression. We can make a decision already, right? So if one is non-zero, then output is true. So condition will be evaluated as a true, right? Condition will be evaluated as true. And this part, right, will be skipped. This part will be skipped, right? So if this second part gets skipped, that means B plus plus is not evaluated. B plus plus will not be evaluated. So B value remains same. So since condition is a true, right, and you will come inside the loop, inside the if block, and you will print A and B values as 1 0, and you will come out of the if and you will print, right, the A and B values again, right? So are we clear on this concept now? How does a OR operator works? This is one of the best feature of OR gate. This is very useful in lot of programs while writing a program, right? Are we clear on this?
Yes.
Okay, thank you. Right now, moving on to the next part, or I will tell you where this will be useful. Many people or the programmers, right, they will use it. Now let's say I want to check the given number is prime or not. Okay, I'm just giving you one scenario here. Okay, I want to check.
So, like, why only logical or, sir? Why can't we use logical and?
Yeah, logical and also works. Logical and also works. If the first input is 0, condition will be treated as false. Logical and also will work. Here my example was only logical or. Correct?
Yeah, got it.
Got it? Are you clear? My example was or here. So I'm explaining about or. Once I finish with that, I'll come to and also. I'm trying to tell how this or operation will help us in programs. We are not just evaluating these things, expressions for simple expressions, right? We will use them to enhance the efficiency of the programs, right? Now, what is a prime number, right? Prime number is, right, it is an odd number except 2, correct? Except 2, right? It is an odd number, right? So only if it is odd, then you will check it is a prime or not, correct? Right? So if all the prime numbers are odd numbers except 2, just for understanding this, where this or operation will help us, right? So we will remove that except 2. Here what you can do is you can write a condition here, if is prime, right? Sorry, not is prime, you can take it as is odd. So this function will check, right, the x is odd or not, right? Odd function will return 1 if odd, right? Return 0 else, correct? So only if it is odd number, then I will go for, right? Then I will go for, right? I'll check is prime. So I am calling two functions here, right? The function 1 and function 2, right? I'm ignoring except 2. I'm telling you except this 2. I'm just using this scenario to explain how this and or will be useful to increase the efficiency of program. Now there is no need of checking, right? There is no need of checking is prime or whether the number is prime or not if it is an even number. So only if it is odd, then check this. If it is even number, don't check this. So this will result into 0. So condition will be evaluated as false. This second part will not be executed. So you can reduce the time of unnecessary calculations. So in such scenarios, right? In such scenarios, we can use or operator or and operator for evaluation purpose, saving time complexity of a program, right? So this was about or operator. Are we clear on this? Are you able to understand how it works? I have to keep checking messages. Okay. Are we clear on this example? How a or operator and operator will work? Right?
Yes, sir.
Thank you, Arvind. Yeah, I saw the messages now. Okay. Now, right, we were talking about operators, right? We will consider some examples here. I have written predefined examples also. but there are some specific examples I want to write and clarify. Okay. Now, let's say, right, let's say there was one question, right, that is to decide, right, decide given number is, right, even or odd. So generally, how do we decide the given number is even or odd? Right? How do we decide? Right?
It
N.
is divisible or not.
Yes, absolutely. So if the number mod 2 is equal to 0, then it is even, else odd. So this is how we decide it. But there is one more concern here. There is one more concern is this one. Modulus.
Number is or not, sir.
Okay. If the number is, can you repeat again? Okay. So let us continue. So this modulus operator, right? Modulus or modulo operator. So this is considered as a most costly operator. Costly operator, right? That means costly operator does not mean that you will spend money. Here you will spend more time, right? Here the modulus operator will consume a lot of time, right, compared to other operators, right? This to evaluate modulus internally, what all operations will be done? Internally, multiplication, division, and subtraction. 3 operations are done if you are using modulus operator, right? So that's the reason we treat this modulus operator as a costly operator, right? Now, let's say, for example, let's say I want to decide the given number is even or odd. So let us take even numbers. So the binary of 2 is 0, 0, 1, 0. So next even number is 4, right? The binary of 4 is 0, 1, 0, 0. Binary of 6 is 0, 1, 1, 0. Correct? Now you can look at all these binary numbers, right? The even numbers in the binary form, right? You can see that the LSB bit, all the LSB bits are having 0, right? So there is a rule that every even number will have its LSB bit as 0, right? Now if you look at odd numbers, right? First one is 1, the next one is 3, 00011, sorry, 0011, 5, 01, 01. Now when you look at these numbers, right, all the LSB bits are 1 for odd numbers. So this property you can utilize to check the given number is even or odd, right? You can use this property to check the given number is even or odd. For example, I can write a condition as if, right, if n bitwise AND of 1 is equal to 0. If bitwise AND of 1 is equal to 0. For example, let's take the n value as 2. So binary of 2 is 0010 and bitwise AND it with 1. So 0001. So when I perform bitwise AND operation, it will result into 0. Right? For even numbers, this will be equal to 0. N bitwise AND of 1 will be equal to 0. So you can write here, right, printf, right, even. Else you can print that it is odd. You can print that it is odd, right? So this way, bitwise operators work more faster compared to other operators because they work at a binary level. That is one of the advantage which we have with bitwise operators, right? Isn't it? Right? So that is what you need to concentrate, right, to write efficient programs, right? Now, for example, let's take one more example, right? That is program, let's say program to count, right, set bits, set bits in a given number, in a given number. Okay, let's say given number. So I'll give you n is equal to 3. So set bits means the bits which are 1, right? So if you think of binary of 3, 0011, right? So how many set bits we have? We have 2 set bits in 3, right? So set bits means the bits which are 1, right? Now, can you tell me what logic you will implement to count the number of set bits in a given number? So how we can implement, or how we can build a logic now for this? Can anyone tell me? If you want, you can message or you can talk. So how to count number of set bits in a given integer number? So the input will be integer number, not binary. So if I give n is equal to 7, it contains output should be 3. For this one, output should be 2. So let me check if I have any messages. No message. It's simple, yeah. It's a simple. You know this decimal to binary conversion, right? So how do you do that? You have some method, right? So 2 ones are 2. That's a remainder 1. So you will start whenever you get 1 as a remainder, you will count it, right? Isn't that
Yes.
right? So we can take a loop while, right, n greater than 1, and we can say something like this: if n mod 2 is equal to 1, count it, right? So once it is done, n is equal to n divided by 2, right? So that is the logic you can use to implement and count it. But the problem is this modulus operator. Just now we have discussed that it's a most costliest operator, isn't it? So that will consume a little bit more time. Now what we can do is we can find an alternate for this. Now let me show you a nice property of bitwise AND. Now let's say the given input is n is equal to 3. So what is the binary of 3? 0011. Okay, this is the binary of 3. Now what is the previous number of 3? What is a previous number of 3? Before 3, what comes?
2.
2, correct? So previous number of 3 is 2, right? So binary of 2 is 0010. Now before starting that, you can see how many set bits are there in the given input. 2 set bits are there. Now what I will do is I will perform a bitwise AND operation between the given number and its previous number. So what is the result? 0, 1, 0, 0. Now, can you see that one set bit is gone? One set bit is removed, right? Now, what is the result here? The result is 2. So previous number of 2 is 1. So binary of 1 is 0, 0, 0, 1. Now, what is the result here? The result is 0, right? So I performed how many times the AND operation, bitwise AND operation is done, right? How many times? 2 times. So this 2, don't you think is equal to the number of set bits in the given number 3? Isn't it? Right? Don't you think, right? The number of times we perform the AND operation is equal to the number of set bits in the given number 3. Correct? So this is a advantage of bitwise AND, or bitwise AND is called as right, or it is used for turning off a bit, right? You can see that one set bit is turned off to 1 means on, 0 means off. So bitwise AND is used for turning off a bit, and bitwise OR is used for turning on bit, right? Turning on a bit, right? So these are the advantages. You need to understand them. How do they work exactly? Then you will be able to crack these things, right? So you need to understand. So for that, you need to solve a lot of examples. First, have a proper foundation. With that, you need to have more on the example. Or let us write a code for this, right? Let us write a code for this. Okay. Now I'll take one online compiler, GDB online compiler, so which I'll be using here to execute a program and show it to you. Right, I will select the compiler as C. I hope the compiler is visible.
Yes, sir.
Okay. I just have a confusion whether I have open Messenger. Messenger is visible or compiler is visible?
Both.
Oh, both. Chalo. Good. Now, see here. Let's start with my program here. Hash include stdio.h. Now, in this one, first thing is I'll start with my main function, because that's where the program will start executing, isn't it? Now, right now, first thing is I need one variable num, right? I need one variable num for input, to store the input. The next thing is I need one count variable, which is initialized to 0, right? Which is initialized to 0. So these are the inputs I can think of right now. So this is sufficient. So the next thing is I have to read a number from the keyboard. So enter number, right? Scanf for reading purpose, comma, ampersand num. Most of the common mistake done by the students is forgetting this AND address operator before the variable in scanf. This is a very common mistake made by the students, right? So be careful with that, where, right, with the scanf, right, you cannot forget ampersand symbol. Now, once I get a number, my next thing is while number is, what is my condition? You can see here. What was the condition? Till where I should keep on performing this operation? Till the number becomes 0. Till the number becomes 0, right? I should keep on repeating this process. So number is greater than 0, opening bracket. So what is the expression I have to execute? Num bitwise AND of num minus 1, right? Num bitwise AND of num minus 1. And every time I perform this operation, I have to increment my count. So once I come out of the loop, I will be having the number of set bits in percentage D is percentage D. So double quote comma, number has become 0. So I need to use some temporary variable. Just for clarity, I'm using this. So once I get the number, I will keep a duplicate copy of number into temp so that I can display it while displaying the output. So temp comma count, right? And in the end, return 0. So now let us execute this and check. So I'll just zoom the screen. So enter the number. So let us enter the number as 3. So number of set bits in 3 is 2, right? Or we will enter a number 7, or you give me any number which you want me to check, or you're sure about how so many bits are there. Any particular number? 9. So 9. So 9 is having 2 set bits. Find out a number which is having more than 2. Right? So I'll enter a number, let's say 11. 11 is having 3, I guess. Yes, 3. So you can check 15, which is having 4. Are we clear how we can work on this example? Right? Now, you guys tell me how to count number of reset bits. Is the logic clear for all of you? So, is the logic clear for you? Or if you want to have a look at a program, I'll just show it to you what I have written here. If you want, you can take a screenshot. So if you want to take a screenshot, you can press print screen and paste it in a Word document. Right? This is how we count the number of set bits. Are we clear on this? No reply. क्या हो गया सब लोगों को? If you want to take a screenshot of the logic, you can take it, no problem. So both the logics are there using modulus operator, using bitwise AND operator, right? You need to perform a bitwise AND operation with its previous number. Are we done with this? Can we move on? Cool.
Yes, sir.
Thank you. Now, the next thing is how to count number of reset bits. Counting set bits is done, right? So I'll just give you a number. You tell me how many reset bits are there. So n, one second. N is equal to 3. You take n is equal to 3. right? How many reset bits are there? N is equal to 3. How many reset bits are there?
2.
No, there are no 2 reset bits. There are more than that. Think of it. Come on. What is the data type of this 3? What is the data type of 3?
Int.
Integer, right? So what is the size of integer?
4 byte.
That
Two
depends.
bits. 2 bytes.
See here, that depends upon whether your compiler is, right, whether your compiler is 16-bit compiler or 32-bit compiler. In 16-bit compiler, the size of integer is, right, 2 bytes. Right? And in 32-bit compiler, size of int is, right, 4 bytes. Now I don't know which compiler I'm working on, right? So if let's say, oh, my pen is not working. 1 second. Okay, so let's say I'm using a 16-bit compiler and the given input is 3, right? I'm working on 16-bit compiler and the given input is 3, right? So how many reset bits are there in 3 with respect to 16-bit compiler?
So 14.
14, exactly, right? See here, for our calculation, we always write the number of bits, right, as 4 bits, right? Whenever we are evaluating, we always write only the 4 bits, right? We always write only 4 bits like this, or binary of 3 is like this. But actually inside a memory, right, if it is 16-bit compiler, inside a memory we will have 16-bit representation, isn't it? Correct? If it is a 32-bit, so in 16-bit the number of reset bits are 14, and if it is 32-bit, the number of reset bits are 30. Correct? So how to count the number of reset bits? So let me check if I have any messages. How to count the number of set bits? Sorry, reset bits.
So using or we can find, sir.
Using or.
Using or operator.
Yes.
Using or operator.
Okay, that is fine. No problem. We can do it. But there is one concern here. Let's say or operator, bitwise.
It should be equal to 0, sir. The condition should satisfy with 0, sir.
But condition will not satisfy with 0. If you are performing OR operation, all 0 bits will keep on turning 1. So what is your exit condition for a loop?
Sorry. One should be, it should satisfy with 1.
But see, if you satisfy with, okay, I understood the solution. I have a constraint, right? Bitwise OR, yes, we can do. But there is one problem here. If I write while, right, some condition here, num is equal to num, right, bitwise OR of num plus 1. Instead of minus 1, you have to do, right, plus 1. So here, okay, this is a scenario. So what is my exit condition here? That is my concern. Exit, how will I?
Should be 1, sir.
No, you can't check num is equal to 1. Right? Num is equal to 1. This is wrong because all the 16 bits or 32 bits will be 1. Am I correct? Like this. All bits will be set to 1.
instead of 1 we can use not 0, right? Not 0, sir.
No, you can't do that. That's a problem here. See, if it is some non-zero number in between, if you perform not of num, right, anywhere it will stop. You won't get a required result, isn't it? Are you getting my concern here? What is the constraint or what is the problem here?
Yes,
Right?
sir.
The problem here is exit condition. So what we can do is we can go with a simple task, right? So you can do 16 minus the number of set bits, or you can do 32 minus number of set bits. This way, one way it is possible. Yes, that is possible. But the concern is which compiler it is. The compiler which I'm using, is it a 16-bit or 32-bit? I don't know. My program should work for both the compilers, isn't it? So what I will do here is I will find the size of integer multiplied by 8, because size of int will give in bytes. So 2 multiplied by 8 minus count. So 16 minus count. So if it is 32-bit compiler, it will give me this. Right? As simple as that. You can use the same logic. So instead of here, instead of this, right here, okay, I'm opening a compiler now. Here, instead of count, you can write it as size of int multiplied by 8 minus count. So whichever compiler it is, doesn't matter. 16-bit int size will be 2 bytes. 32-bit int size will be 4 bytes. So this program will work irrespective of any compiler. Sorry, I should have changed reset bits. I should change the name here as reset bit. One second, let me change. Right, reset bit. Right. So I'll enter the number as 3. You can see the number of reset bits is increase is 30. So 30 means this compiler is 32-bit compiler, because the size of integer is right, size of integer is 4 bytes. Are we clear on this example, or do you guys have any doubts? Should I show you the code? One second, I'll just show you the code. So this is the only modification which I did. Clear? Makkale, are you clear with this? Come on, dude. Somebody make some noise.
Yes,
Yes,
sir.
sir.
Thank you. So if you have a doubt, you should always ask. I always try to do it in such a way that everybody will get clear and have a zero doubt. But some cases I will leave. I want you guys to have a doubt at some point. Okay. So this is one kind of, or one way of implementing it in, right, counting number of set bits. Now let us concentrate on something called as a prime number. Have you heard about it? Prime number. I think everybody heard about this, right?
Yes.
So what is the definition here? Definition says, right, if number is divisible by 1 and itself, then it is prime number, correct? Or is it wrong?
It's correct, sir.
It is wrong, because every number is divisible by 1 and itself. Here I forgot one word, that is only. If the number is divisible by only 1 and itself, then it is called as a prime number. Right? Now, this prime number program has been asked very much or many times, and they will still keep on asking this. Now, I'll just give you a scenario. Infi TQ. I think you got infi TQ, right? I think you guys have heard about this InfyTQ. These people have asked a question based on prime number, right? Only 4% people were able to match company expectations. Right? Number of people attended is like in lakhs of students have attended entire India. Only 4% of students were able to match company expectations. Why is this? Right? Or if you are using Hacker Rank or what are there are some websites, Hacker Rank, and what is that? Hacker Earth, right? Lead Code. Many portals are there where you can practice your codes, right? You have always, many people have come across with this TLE, that is time limit exceeded. Correct? Anybody who has come across with this? Only if you have worked on such compilers. Time limit exceeded. Right? So here, why this one comes, right? Why this one comes, right? It is because, right, there is one hidden test case. Hidden test case which monitors time taken by your program to get result. This is the hidden test case. Most of the companies have this. See, usually they will give a proper time only. If it works for basic logic also, it will work. But for example, InfyTQ, they have given a very small time limit. The time limit was in microseconds, very less time. So they wanted a solution within that time or the result within that time, right? For this prime program. So this is the concern. And the logic, what is the logic everybody writes for prime number, right? Let us discuss on that. Are you aware about prime logic? Prime number logic? Yes. So you guys are aware about it. So that means I can finish it in less time. Now, right, the prime number basic logic. Let's say the given number is n is equal to 13. And let's say the given number n is equal to 13. And I want to decide this is the 13 is a prime number or not. So there is one method. So let's write down the numbers starting from 1 to 13. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Sorry, 13 is last. Okay. So these are the numbers starting from 1 to up to the given number, that is 13. Now the number should be only divisible by 1 and 13. Correct? So that means let us remove 1 and 13. So the number 13 should not be divisible by any of these numbers, which is also correct, isn't it? The 13 should not be divisible by any of these numbers. But if I do it only to check the given number 13, I have to do 11 iterations. I have to do 11 iterations because I have to check with every number, isn't it? I have to check with every number, right? So what I can do is I can go for, right, factors of a given number, right? I can go for factors of a number, right? So how do we find the factors of a number? Factors of a number are always present in half of the given number, right? So 13 divided by 2 is how much? 13 divided by 2 is how much?
6.5.
That is a mistake. That is a mistake here. I am doing a integer division, which is equal to, right, 6. Right? So we are so much possessed about our mathematics. Your answer is correct, but according to the programming language, we are doing an integer division. If I write 2.0, then your answer is 6.5, right? Now here the answer is 6. So factors of a number are always present from 1 to half of the given number. So what I can do is, instead of checking with all, I can check only starting from 2 up to 6. I can check, right? Whether 13 is not divisible by any of these numbers, that is 2, 3, 4, 5 or 6, then it is called as prime number. So I need these numbers. I need these numbers 2 to 6. So how can I construct it? I will take one loop starting from 2 till I should go up to n divided by 2 and I plus plus. So inside this loop, what I will do is I will check a condition. If n mod I is equal to 0, then, right here, what I need is, I need one status indicator. I need one status indicator. Let's take variable as x. Initially, I will keep it as 0. When this condition becomes true, then I will set x is equal to 1 and break. So here what it tells us is, what this one tells us here is, right, if 13 is divisible by any one number, let us assume that this number is divisible by 2, then there is no need of checking for 3, 4, 5 and 6. So stop there and come out. So once I come out of the loop, I should know whether this condition n mod I is executed or not, isn't it? Right? N mod I is equal to 0 is executed or not. So for that, I'm using this x is equal to 1 as a status. So once I come out of a loop, what I will do here is, I will check if x is equal to 0. That means the condition is not executed. If x is equal to 1, that means the number is divisible by a factor. The condition is executed. So if x remains unchanged, then I will print it as prime. Correct? Else I will print it as not a prime. Correct? Are we getting this? Are we clear with this logic?
Yes, sir.
Any confusions or any doubt? This is a very basic logic which we use. Here, the problem with this logic is, takes a lot of time to check one number is prime or not. Right? It takes a lot of time. Right? Now, what are the programs which are associated with prime numbers? Right? The programs which are associated, or the programs, or which kind of programs will be asked. That is, one is program to print, right, primes up to n. This is one question. Second one is program to check given number is prime or not. Third one is, right, program to print sexy prime numbers in a given range. So this was the question which was asked in InfyTQ. This was the question which was asked in InfyTQ, I think last year. Right? This was pretty easy. Sexy prime number means, right? Sexy prime means, right, pair of primes with difference 6. Right? Now, see, I want to print prime numbers up to n. Starting from 1, I have to print prime numbers up to n. So that is a concern here, right? Because if I'm using, right? That is my concern here is, right, modulus operator, right? That will take a lot, means lot of time if I go with that. So what I have come across here is, right, here there is one algorithm called as Sieves algorithm. Right? This is called as Sieves algorithm. So let us see what is a Sieves algorithm. I hope you guys will concentrate now, right? Because don't miss it. There is a lot of things which I want to show you, and the time is very less. Okay. Now, so what is Sieves algorithm? Here, the first thing is, right, a number is called as a prime number, right? A number is called as prime number if it is not divisible by, not divisible by any prime, right? A number is called as a prime number if it is not divisible by any of the prime numbers or any of the prime numbers, right? So then it is called as a prime number. So this is what the Sieves algorithm means. Now let us see how we can utilize this algorithm to generate prime numbers up to n. Right? Can we start now?
Yes, sir.
Thank you. Just a second. Okay. So let us start. Okay. So first thing is, right, program to print prime numbers up to n. Let's say n is equal to 30. Right? N is equal to 30. Right? Now, what I will do is first I will write down all the numbers from 1 to 30. Right? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. So finally we could write down all the numbers. Now, so here, how do we utilize this Sieves algorithm to generate prime numbers up to n, that is 30? So the first number 1 is not a prime number, that we know. So let us ignore that. Right? Now, which is the next prime? The next prime number is 2. Right? The next prime number is 2. So keep 2 and remove multiples of 2. Multiples of 2. So remove all the multiples of 2. 6, 8. So once again, 9 I have removed it by mistake. Right? 10. So remove all even numbers. Right? So now I have removed, right, multiples of 2. Right? Now the next prime number is 3. So keep 3 and remove multiples of 3. Right? So let's remove multiple of 3. Multiple of 3 is 9 and 15, 21 and 27. So I've removed these numbers. Now till where I have to do this, right? Till where I have to do? Till I star I less than or equal to n. This is the exit condition. This is exit condition. Right? This is called as exit condition. Now see here, what is the number I have picked? 3. 3 multiplied by 3 less than or equal to 30. So it becomes 9 less than or equal to 30. Yes, I can remove multiples of 3. Now take 4. The next number is 4. But here, the next number 4 is missing. That means multiples of 4 are already removed. Multiples of 4 are already removed. So the next number is 5. So keep the number 5. Remove the multiples of 5. So multiples of 5 is 25. This is remaining, right? Now what is the condition, right? 5 multiplied by 5 less than or equal to 3, right? Which is 25 less than or equal to 30. So it is true. So I can remove multiples of 5. The next number is 6. So let's check the condition. 6 multiplied by 6 less than or equal to 30, right? 36 less than or equal to 30. Condition fails. When condition fails, stop your work. The remaining numbers are your prime numbers. The remaining numbers are prime numbers. Don't you think all of these numbers are prime numbers? Are we correct?
Yes.
Right?
Yes, sir.
So this is the most easiest way of generating prime numbers up to given number. Right? So let us see how we can implement this logic. Right? How we can implement this logic, right? So here what I will do is I will write a small program here. I will go to the compiler, right? I'll clear the previous program. I'll start with hash include stdio.x. Now the first thing is I will write a main function, right? Main function. Inside this I want
Hello, sir.
Yeah, just give me.
hello.
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 Hello,
I'm
sir.
sorry, ma'am. There was.
You're there, no, sir?
Am I audible now?
Yeah, yeah. Now
Yeah,
you're audible. Meantime,
actually,
you're not audible.
yeah. I know there was a power shutdown here all of a sudden. So
Okay, sir.
because of that reason, it happened.
Okay.
Anyways, right?
Yeah, yeah.
So Okay, coming back to the code. I'm really sorry, kids. There was a power shutdown here. Okay, so I'm trying to write a code here, right? I'm trying to write a code. Okay, so printf, enter the number. I want only one number as an input, right? I want only one number as an input. So once I get that number, I will print primes up to percentage d. Somebody, ma'am, mic is on. Ma'am, 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 somebody's mic is on. Hello. Okay, thank you. Now, so coming back to this, I will read one number. I will read one number from the keyboard, and I will just print that number here. So prime numbers up to given range. Now what I will do is I will call a function primes up to. So I will call a function primes up to, and I will pass number as a parameter. So that function will take care of printing every prime numbers up to that, right? So what is the function? So function return type is void. Function name is primes up to, and there is one integer number which I'm passing as a parameter, right? I'm passing integer number as a parameter here, right? Okay. So what I will do inside this is, first I will declare I want all these numbers 1 to 30. I want numbers from 1 to 30. So for that, what I will do is, I will take an array. I will take an array here, right? Okay. So I will take an array, right? One second. This. Okay, one second, guys. This. Okay. So there first we need to consider one array with some elements. So how many numbers I require? If my number is equal to 30, I require numbers from 1 to 30. Okay. So what I will do is I will declare an array, right, with a size 31, right? So what will happen here? So you will create so many memories here, right? You will create so much, you will create one entire array with so much of memories. So you will have indexing like this: 3, 4, 5, 6, 7, 8, 9, 10. So up to 30, sorry, 29 and 30. So up to 29 and 30. So these are the array memories and their respective indexes, right? These are the array memories and their respective indexes. So when you declare an array, right, because for this logic I need a numbers from 1 to 30, right? So if I declare an array with size 31, I will get array like this with a index number starting from 0 up to 30. So what I will do here is, first I will declare, right, array called as prime with a size n plus 1. So I will declare array with a size prime plus 1. Okay. Now after this, right, after this, what I will do is I will fill all the array elements with value 1. Right. Now see here, I will take a for loop. I is equal to 0, I less than or equal to n, and I plus plus. So I will fill all array elements as 1. Initially, I will keep all the elements as 1. Now see here. So I will keep all these elements as 1. Right? I will keep all these array elements as 1. Okay. Now the next thing is, right, the next thing is these the one which I have filled in all the array elements, that will act as a status, that will act as a status, right? Now, so once I did this, right, once I did this, right, what is my next task? My next task is I need to start removing multiples, right? My next task is I have to start removing multiples, starting from where the first prime number is 2. What is my exit condition? I star I less than or equal to n and I plus plus, right? So once I come inside this loop, so this loop will give me values from 2 to, this loop will give me values from 2 to 30. Okay, right? 2 to 30. So first time I value is 2, right? First time I value is 2. So what I have to do with this, I have to take one more loop starting from j is equal to I star I. So what is this j is equal to I star I, right? So I value is equal to 2. I value is equal to 2. Now j value becomes how much here? J value becomes 4. Till where, right? J less than or equal to n and j is equal to, we'll do that. So j is equal to 4. So what I have to do is I have to fill all these array elements with the index j as 0, because j will give me multiples of 2, multiples of 2. So what will happen here is this element will be made 0. Now this one will be made 0, this one will be made 0, this one and this one. The numbers, the index numbers which are multiple of 2, all of those index elements are made 0, right? So before doing that, right, what I will write here is I will check if prime of I is equal to 1, then only proceed for removing. J is equal to I star I, comma, right, j less than or equal to n and j is equal to, how do I increment? Now see here, initially I value is equal to 2 and j value I have started from 4. So I made prime of 4 as 0, right? I made prime of 4 as 0. I made this. Now which is my next multiple of 2? My next multiple of 2 is j is equal to j plus I, correct? J value is equal to 4 plus 2, right? Every time it gets incremented by I. So that's the reason you can increment it by I. J is equal to j plus I. So inside this, you can make all those multiples of those indexes as 0. Once you come out of this loop, once you come out of this loop, right, you can print all the prime numbers here. For I is equal to 2, I less than or equal to n, I plus plus. So which numbers will become prime here, right? So initially I have removed 2. Now let's take I is equal to 3. So when I is equal to 3, if I take, I will make these numbers as, right, 0, right? Multiples of 3 I will make 0. Now there is one condition I have written before removing multiples, that is prime of I is equal to 1. This condition, why I have written this condition is, now when I value becomes 4, right, so prime of 4, it is already 0, it is already 0, correct? It is already 0, right? Then there is no need of removing multiples of 4. Directly go for the next number, directly go for the next number, right? So when you make all of them, then you can print all the numbers with element values as 1. You can print all the indexes. You can print all the indexes with the element as 1. Right? You can print. I will just show you here. I will start a loop here from I is equal to 2, I less than or equal to n, I plus plus. So here I will check if prime of I is equal to 1. That means it is a prime. So which one is a prime here? Your index will act as prime. So this will print prime numbers up to a particular given range. Let us execute this and check. Okay, j variable is undeclared. So let us declare the j variable I comma j. So I've declared j variable also. Now give me a number up to where I have to print. Up to where I have to print. Let's say 30 only I will take. 30. Now it is printing 6, 7, 8, 9, 10. Every number it is printing. So there is some problem, right? There is some problem, right? That is, let's check what is the problem in the code. So I have made all the elements as 1 in the beginning, right? Okay. And then I'm writing a loop which will generate the numbers, right? Which will generate the numbers. Okay. It will generate numbers from 2 to up to n. So if prime of I is equal to 1, so if the number is, right, prime of I is equal to 1, then only go for removing this should be j, prime of j. By mistake I have written prime of I, so that should be j, because j loop will give us prime numbers, right, multiples of primes. So 30. Now can you see that are we able to print prime numbers in the given range? Can you see? Are you able to see we can print prime numbers up to a given range? I'm really sorry that there was a power shutdown in between. Right? If you want me to explain again, right, I will explain it now. If any part is missing, I'm assuming that you have not missed much. Are you clear with this? What we are doing, how we are printing? See, I need a collection of numbers from, if I give n is equal to, 30, I need a numbers from 1 to 30. So what I will do is I will declare one array prime of n plus 1, right? Prime of n plus 1. So which is nothing but prime of 31. So what all, right? How many elements I will get here? I will get 31 elements with the index starting from 0 up to 30. Right? I will get the index numbers starting from 0 up to 30. Right? Up to 30. So now I will use these index numbers as my numbers for the program. So initially I will fill 1 into every memory. Initially I will fill 1 into every memory. Then what I will do is I will take first 2 and then I will start removing multiples of 2. So multiple of 2 is 4. So wherever the index 4 is there, I will make that element as 0. Next is, right, 5, which contains 1, 6. So multiples of 2, I will make all of those things as 0. Similarly, multiples of 3, I will start from 9. So I will make every number as 0, right, if it is a multiple of prime number. So once that entire process is done, and you have completed that exit condition I star I less than or equal to n. Once you come out of that loop, you have to print the prime numbers from starting with this range, because the first prime number is 2. So you need to check if the element is 1, then it is a prime number. If the element is 0, it is not a prime number. So you need to print the index. You need to print the index, right? 2, 3, 5, 7, 11, 13, like that. You need to print the index whose values are 1 starting from 2, right? That is what I did. This is for printing prime numbers. You can see that I am printing the index I instead of a value. So the index numbers acts as, right, prime numbers here. So are you able to understand how this Sieves algorithm works to generate prime numbers up to a given range? Right? If you want, you can take a screenshot. In the main function, I'm just sending a number to this function. If you want to take a screenshot, you can take. Once it is done, let me know. We'll go for the next program. That is checking the given number is prime or not using Sieves algorithm. So nobody's replying here. What happened? No reply at all. Okay, done. So if it is done, let's move on to the next example, right? The next example is program to check the given number is prime or not. Now, this example is very simple. You can do it in a more easier way. What we will do is we will write a function called as is prime. Is prime. So we will write a function called as is prime. So this function, what it does is, right, is prime. Function name is prime. What it does, it takes one parameter which is of type integer. It takes one parameter which is of type integer. So this will return 1 if prime, return 0 if not a prime. Right? So that is what we will do it. So to implement this logic, right, right, we will come across with, right, we'll come across with this, right, that is, right, we will use Sieves algorithm, right, to check the given number is prime or not. Now let's see how we can do that, right, here, right. So now what I will do is I will write my main function, right, opening bracket. I want one number as an input. I will enter the number from the keyboard, right, and read it, right. So scanf double quote percentage d double quote comma ampersand num. So I got the number, right. So I will check, I will call a function is prime of num. So if it returns 1, the condition becomes true. So I will print, right, prime number, right. I will print it as prime number. So else I will print it as, right, I will print if not prime, right. So return 0. Are you clear with this, what I'm writing here? Okay, sorry, I have removed that program. 1 second, I'll just scroll down with that. Okay. Here, I. So I'll scroll down. You can take a screenshot if you want now. One of your friend wants a screenshot. You can take a screenshot now. I've scrolled down. Previous program. Done. If it is done, drop a message or use a mic.
Yes, sir.
Thank you. Now, what I will do is I'll continue with my program. So I have to check the given number is prime or not. So I have written a function here is prime. This will return what? This function will return 1 if it is prime. If it will return 0 if it is not a prime. So what we will do is the return type of the function, it is returning either 0 or 1, both are integer. So return type of the function is int. So is prime, and I'm passing one parameter, let's say n. I'm passing one parameter, that is n. Now here, first thing is, what are the possibilities of n? What are the possibilities of n value, right? N value, first thing, first possibility is that n value can be equal to, n value can be equal to, 1 second. So n value can be equal to 1, right? So if it is equal to 1, is it a prime? If it is equal to 1, is it a prime?
Yes.
1 is equal to, n is equal to 1, is it a prime?
Yes, sir.
Array, 1 is not a prime. 1 is not a prime. The first prime is 2, not 1. Am I clear? 1 is not a prime number, right? So if n is equal, possibility of n value is 1. So you can check condition here. If n is equal to 1, so it is not a prime. If it is not a prime, what I have to return here? Should I return 0 or 1?
0, sir.
0. Chalo. Now, if n is equal to 1, we will return 0 because it is not a prime. So one more condition. If n is equal, sorry, n less than or equal to 3, what are the possible values? See here. First condition is n. First condition is n is equal to 1. First condition. Second condition is I have written n less than or equal to 3. So what are the possible values for the second condition? What are the possible values of n? Right.
2 and 3, sir.
2 and 3.
3.
So the possible values are 2 and 3. So 2 and 3, are they prime or not a prime? 2 and 3, are they prime or not a prime?
Prime, sir.
So they are prime numbers. So if they are prime number, I have to return 1. Correct? Done. The next thing is, what if the number is divisible by? What if the number is divisible by 2 or number is divisible by 3? Is it a prime or not a prime? Prime number?
Not a prime.
Not a prime.
Not
So
a prime.
this is next condition. If number mod 2 is equal to 0 or if n is divisible by 3, then it is not a prime. Return 0. The next thing is, I have checked for 1, I have checked for 2 and 3 for prime, I have checked 2 and 3 for not a prime. Both the things are done. The next thing is, I have to check the remaining prime numbers. That is, right, 5, 7, right, 11, 13, right, 17, 19. Can you see here, there is a pattern for prime numbers. Now, here the difference is 2 and here the difference is 6. Can you see? 5 and 7, difference between 5 and 7 is 2. and difference between 5 and 11 is 6. Are you able to understand this difference? Right?
Yes, sir.
I have checked with 1, 2, and 3. This is for not a prime. These two I have checked for prime, and also I have checked the number is divisible by 2 and 3, right? For not prime. So the next thing is I have to check for remaining prime numbers. I have to check for remaining prime numbers. So what is the definition says of Sieve's algorithm? If the number is not divisible by any prime number. So I have to generate all the prime numbers now to check whether it is divisible or not. The given number is divisible or not. So how do I generate prime numbers? So my next prime number is I is equal to 5, right? So what is the exit condition? Exit condition is I star I less than or equal to n and I plus plus. Sorry, not I plus plus. We'll keep that aside, right? Inside this, what I will do is, right, I will check if n mod I is equal to 0. So what is the I value here? Initial first value of I is 5. So the first value of I, one second. So I am writing a condition here. If n mod I is equal to 0, right? So here, your first time you are checking n mod 5. What we will do is we will also check n mod I plus 2 is equal to 0. So what is the second number? N mod 7. So you checked with 5 and you checked with 7. So what is the next prime number after 7? What is the next prime number after 7? Currently I is equal to 5. So when I is equal to 5, you are checking condition or whether the number is divisible by 5 or 7. So what is the next prime number after 7? You can see here.
11.
11, right? So the next prime number is 11. So I have to check for 11 and 13. So what is the difference between I is equal to 5 and 11? The difference is 6, correct? The difference is 6. So here you can increment the I value by 6. I is equal to I plus 6. And here you can check the condition as n mod I plus 2 is equal to 0. Right? So if it is divisible, it is not a prime, so return 0. Now, the last option says that, see, the given number n given number is equal to 1 fails. Given number less than or equal to 3 fails. Given number is not divisible by 2 or not divisible by 3 fails. Then given number n is not divisible by any prime. Then what the given number is? Then the given number is, come on guys, if the number is not divisible by any of the prime, then it is a prime number. So return 1 in the last. That's it. This will check for all the prime numbers. This is the fastest way of checking the given number is prime or not, right? Let me show you, execute and show you. Give me a prime number, any big number which is a prime number. I'll check for small numbers. 13 prime number, right? 13 prime number. So I will give 17, which is a prime number. I will check for not a prime number, which is 18, not a prime. Let's check for 2 also. 2 prime number. Any bigger numbers which are prime? 107.
97.
97. Okay. 107 is a prime. 97. 97. Prime number. You can go for 1007 also. 1007. Not a prime. 10,007 is a prime number. 10007. Prime number. 1,07,000 is not a prime, but 10,07,000 is a prime number. That's how it goes. Prime numbers are arranged or they are present in some common pattern there, right? Are you clear with this code? Do you guys have any doubts with this? 223. Let me check 223. One of your friend is giving me that. So 223. It is a prime number. Can you see it? Durga Shetty. Are we clear? 223. Right? So if you want to note down the code now, or do you want me to send it in the messenger? I think I can send. Let me check. I've never tried. Yes, I have sent the code in prime number also. Let me know whether you have received it or not. If you want, you can take a screenshot also. So are we done here? Is this clear how it is working? Okay. So the last program is, right? Last program is prime numbers, to print sexy prime numbers in a given range. Now, for example, let's say, right, to print sexy primes in a given range. Sexy prime numbers means what? It is a pair of prime numbers whose difference is 6. Now, let's say here, right, the given range is m is equal to 1 and n is equal to 30. So you need to print the prime numbers whose difference is 6. That is 2 and 7. Sorry, 2 and 7 difference is 5. So you can print 5, 11, 7, 13, right? And next is, right, for example, so you need to print a pair of prime numbers in the given range, that is 1 and 30, all the pair of prime numbers, right? So you can print 11 and 17 like this, right? The question is clear. We can just finish it in 2 minutes. It doesn't take much time. Now see here, we will use the same thing, right? But here my main function will change a bit. So I need two numbers here. One is m, comma, another one is n. So printf, enter the range. So enter the range, semicolon. So scanf, right, %d, comma, ampersand m, comma, sorry, comma, ampersand m, comma, ampersand n, right? Okay. Now, right, once I get the range, so I will take one for loop. For that, I need one I variable, right, for a loop iteration, right? For loop, I is equal to starting from m, semicolon, I less than or equal to n, comma, I plus plus. So inside this loop will give me values from m to n. So inside this loop, what I will do is I will check is prime of I. And also I will check is prime of I plus 6. So when both are prime, when both will return a value 1, when both will return value 1, see here, if is prime of I and logical and of is prime of I plus 6. One of your friend was asking, right? Logical and or. See, if both the conditions are true, right? Or both will return 1, then only the condition, final condition becomes true. So when both the condition becomes true, right? Or this entire condition becomes true, I can print here double quote inside bracket percentage d comma percentage d, close the bracket slash n comma I plus 6, right? So this way you can print all the pair of, right, all the pair of prime numbers whose difference is 6. Now let us execute and check, right? So I will give the range as 1 and 50. Now you can see, right? Can you see all the prime numbers? Pair of prime numbers whose difference is 6. Now, is it correct or do we have any problem here? Between the range 1 and 50. If there is any problem, please let me know. A pair of sexy prime numbers in the given range 1 and 50. Do we have any problem or is it correct? Sumaya Sheikh, she has observed. Now, can you see here? It is crossing 50, isn't it? Now, what we can do is we can reduce our limit of a loop. Here, limit of a loop, you can write it as n minus 6. Then it will come within the range. N minus 6. Then it will come within the range. So is it coming within the range now? Because you are checking I and I plus 6 together. So your maximum limit is n minus 6 because you're doing plus 6 inside the loop already, right? So the maximum limit is n minus 6. That is the last range. Are we clear with this example? Do you guys have any doubts in this or you want to check with the code? I think code is not visible in one entire screen. I'll just share it in a Can I share it in a messenger? Can I share it in a messenger? Okay, super. So I'm sharing it in a messenger. I think return 0. Last part return 0 and closing bracket is not coming. So I'll just send it return 0 semicolon and closing bracket. That part was not coming, so I've sent it separately. Right? So if you have any of the doubts, right, you can come prepared by tomorrow. Tomorrow we will continue with the same topics, but we will do MCQs. At least I'm targeting for more number of MCQs tomorrow. So it all depends upon you guys how fast you respond. Right? And please ask your friends not to skip the classes. Otherwise, there is no point in learning this. Okay. So, assuming that there are no doubts, right? because I've received messages, no doubt, right? So we'll see you in the next session, right? As and when it is scheduled, right?
Thank you, Mr. Vishal, for briefing the students about the fundamentals of C. I would like to thank the management, organizers, and the entire BCA team for their effort towards the program. Thank you, students, for your participation. Good day.
Thank you, ma'am.